So boys and girls, if you are trying to program in RSLogix 500, you must need to know these addressing indexes of RSLogix 500. So let's start our session now. So for input addressing, the address goes like we need to put I colon 0.0 slash 0 enter. And okay, so if you can see, I have given I colon 0.0 slash 0. In this addressing, the I indicates input index, O indicates slot number in modular PLC, and if the PLC is compact, the number is 0, and the next 0 indicates the word address, which is 16-bit, and the last 0 indicates the bit number from those 16 bits. So this is about the input addressing, and for output addressing we can give address as O colon 0.0 slash 0 enter, and the output address is as same as our input address. The O indicates output index, and the 0 indicates the slot number, and the next 0 indicates the word address, and the last 0 indicates the bit number, just like our input address. So this is about the output and input addressing. So now let's move further to our next addressing index, which is for the status bit. You can see these status bits here, and these status bits are used for, as the name suggests, the status. Like it is showing some status. Like status in math instruction shows the overflow trap, carry, overflow, 0 bit, sign bit. So it is like if math instruction comes with the result where the carry is happening, then this bit goes high, and if the math instruction results in overflow, then this bit gets high, and if the math operation has got 0, then this status bit goes high. Like that the status bit is used. And our next addressing index is bit memory. So the binary bits are used for temporary addressing of inputs and outputs. So let's check how we can use them. So if I want to use this 0 number bit to my input, I can just drag and drop here. So you can see the 0 number bit is addressed on the first input, and if I want to address my output by the second bit, I can use it here by just dragging here. So you can see I have dragged the bit address to our output. So we can use the binary bits for temporary addressing. It is because we have limited inputs and outputs for the module. So if we want to use our inputs and outputs extensively, we can just replace them with the binary bits so that our inputs and outputs can be used in further applications. So this is the use of memory bit or bit memory, whatever you want to say. And the next is our timer addressing index, which is used for addressing the timer. So let's just check how we can use the addresses. So for timer, we can use the timer addressing index. We can just drag this T4 colon 0 to our timer block, and it will just get its address by just dragging. And if you don't want to drag the address, you can just type here T4 colon 0 enter, and now the timer address is assigned here, and you can assign the 10-second preset value as well, about which we will talk in our upcoming sessions in timer session. So this is about the addressing of timer. So let's move further to our counter addressing. So for counter addressing, we need to take one counter operation here. I will use CTU, which is up counter, and if I just want to address this counter, I can simply type here C5 colon 0 enter. So now we have given the address to our counter, that is C5 colon 0, and now this counter is being recognized using this address which I have given here. So if you just don't want to give the manual address, you can use from the project tree the counter, and if I just drag this here, you can see I can use the C5 colon 0 address for our count. So this is about the counter addressing. So the next is our control data register, that is used for bit shifting, like bit shifting to left, bit shifting to right, first in first out, and last in first out. We can use these for those kind of applications. So this is about the control data register. And now the next is integer, that is our N7 colon 0, which is used to store the integer values like the whole numbers. And if it is 16-bit, it can store the value ranging from -32768 to +32767. So this is the integer data register. about which we can talk in our upcoming sessions where I am going to use the scaling instruction. So we need this integer data register in scaling operation. So we will talk about in upcoming sessions. So let's move to our last addressing index, which is about floating point, and it is used for storing and manipulating decimal values. Like if I just want to store value which has fractions in it like 3.14, 2.79, etc., I can use here floating point, but I cannot use integer data register here because the integer data registers can't store the decimal values or fractional values. So this is about the addressing indexes. So if I just want to summarize this session, I will summarize like this. We can use our input address for addressing our input instructions, which goes like I colon 0.0 slash 0. You can use the 16 bits from the word address 0 or word address 1 or the word address you have. So for output, we can use the output addressing from O colon 0.0 slash 0 to O colon 0.0 slash 15. So this is also 16-bit addressing. And next is status bits, which are used for math operations like to show the carry, overflow, zero, negative, these kind of math status. And the next is memory bits, which are temporary addresses for inputs and outputs. And the next is timer, which is used for addressing the timer instructions. And the timer addressing ranges from T4 colon 0 to T4 colon 255. And next is our counter, which is used for addressing our counter instruction, which starts from C5 colon 0 and goes up to C5 colon 255. And next is our control data registers, which are used for bit shifting and first in first out, last in first out, etc., the operations like this. And next is our integer data register, which is used to store the whole numbers from negative 3 to 768 to positive 3 to 767. And the last register is floating point data register, which is used for storing the large numbers like decimal numbers, example 3.14 and 20.10, etc. So this is about the addressing index for the RSLogix 500. So if you have any query, let me know in the comment section. And if you learned something from this video, make sure to hit that like button. And if you really enjoyed this session, you can share this video to your friends and colleagues so that they can also learn the Allen Bradley. And in the next session, we are going to see some basic programs in Allen Bradley. So to see that, you need to hit that subscribe button and make sure you turn on the bell icon so that if I upload any video, you can easily get notified. So with that, it's time to solve the problem which I have given in previous session and which goes like this, and the answer is this. So I hope your answers were correct. So if it is correct, then please comment correct, and if it doesn't, you need to improve. So that is it for this session. See you in the next one. Bye.